A 4 metric ton truck traveling at 90 km per hour collides with a stationary 1 metric ton car. If the vehicles remain joined together, what is their velocity immediately after collision? What percentage of the kinetic energy is lost as a result of the collision? Okay, this is not different from the situations we discussed so far. Now, we have a 4 metric ton truck traveling to the right at 90 km per hour. Convert that to meter per second. It is 25 meters per second. And it is going to collide with a poor car right there. And the two joins together and moves forward. That is the situation. So mass of the truck M1 is 4,000 kilograms. Its initial velocity before collision V1I is 90 km per hour. That is 25 meters per second. Therefore, its momentum before collision P1I, look at that, initial momentum of the first object, P1I, is its mass times the initial velocity, and that is 10 to the power 5 kilogram meter per second. Okay? The mass of the car is M2, that is 1,000 kilogram, 1 metric ton. A metric ton is 1,000 kilogram. So 1 metric ton is 1,000 kilogram. And before collision, the car is at rest. V2I equal to 0. Therefore, what is the initial momentum of the car? What is the momentum of the car before collision? P2I equal to 0. So what is the total momentum of the car truck system before collision? Pi. Initial momentum of the system is P1I plus P2I. That is, P1I is 10 to the power 5 kilogram meter per second. P2I is 0, therefore the total initial momentum is 10 to the power 5 kilogram meter per second. Alright? We need to find the velocity of the system after they collide. They collide, joins together, and let's assume that the combined velocity of the wreck after they collide is V sub f. Let Vf be the velocity of the combined system after collision. Then the combined, what will be the combined mass after collision? The mass of the truck is 4 metric ton. The mass of the car is 1 metric ton. The total mass is 5 metric ton. That is 5,000 kilograms. So what is the momentum of the system? That means the truck and the car joined together. It will be 5,000 kilogram times Vf. That will be the final momentum. Let's write that down. So Pf, the final momentum, is 5,000 Vf kilogram meter per second. We know the initial momentum of the system. We now know the final momentum of the system. Apply the conservation of momentum. Pi must be equal to Pf. Therefore, 10 to the power 5 kilogram meter per second equal to 5,000 kilogram times Vf. Can we solve for Vf? Yes. Vf is 10 to the power 5 divided by 5,000. That is 20 meter per second. After the truck collides with the car, they join together and move in the direction in which the truck was coming. That's why the final velocity is positive. Okay. B. What is B part? In the process of collision, some kinetic energy is lost. We need to find the percentage of kinetic energy lost. Alright, what is the total kinetic energy of the truck and the car before collision? Kinetic energy is 1/2 mv squared. So Ki, initial kinetic energy, is the initial kinetic energy of the truck plus the initial kinetic energy of the car. Well, we know the mass of the truck, we know the initial velocity of the truck. Do you remember that value? Initial velocity of the truck? 25 meters per second. Tell me, what is the initial kinetic energy of the car? The car initially was at rest. Its initial kinetic energy is 0. Alright, so this is now 1/2 m mass of the truck times its velocity squared. This is the initial kinetic energy of the truck plus the initial kinetic energy of the car is 0. And that gives me Ki equal to 1.25 times 10 to the 6 joules. Now I urge you, when you watch these lectures, always be ready with calculator, paper and pencil. Work these out with me. Be very active in learning. Alright, so the initial kinetic energy is 1.25 times 10 to the 6 joules. What is the final kinetic energy? After collision, they join together so that their total mass is m1 plus m2, and that is 5,000 kilogram, and the common velocity is Vf. So the final kinetic energy is 1/2 m1 plus m2 Vf squared, and that will be 1/2 of 5,000 times, we calculated Vf as 20 meters per second, and that is 10 to the power of 6 joules. Alright, what is the kinetic energy lost? Kinetic energy lost is initial energy minus the final energy. Is that right? That's the amount lost. That is 1.25 times 10 to the 6 minus 10 to the 6. Can you put that in your calculator and give me a value? Is this right? 250,000 joules. In the process of collision, we say the kinetic energy lost is 250,000 joules. Now tell me, is this consistent with the conservation of energy? Can energy be lost? Well, one form of energy can be lost, but that should appear in other forms of energy. But total energy cannot be lost. Kinetic energy can be lost. Now tell me, what happened to this lost kinetic energy? The truck comes and hits on the car, and in the process of that hitting, there is a loss of kinetic energy of 250,000 joules. What happened to this lost kinetic energy? Can you think about it? Well, some part of that is used in doing work on the car. Is that right? The car has been made into half its value, or half its length. Is that right? The car has been squished up. The energy needed to do that work come from this lost kinetic energy. And there is a lot of sound, vibrations, and many other forms of energy. So this lost kinetic energy is not simply lost, it's being converted to other forms of energy. What is the percentage of kinetic energy lost? Now, how do you write the lost percentage? Now, it will be the amount lost divided by the original value multiplied by 100. That's how you calculate the percentage lost. The amount of energy lost divided by the original amount multiplied by 100. Look at that. Ki minus Kf over Ki multiplied by 100. That will be the percentage of energy lost. That is 250,000 divided by 1.25 times 10 to the 6 multiplied by 100, and calculate that for me. I got it as 20%. 20% of the original kinetic energy of the truck has been lost in doing work against that, well, in doing work on the car. Also work is done on the truck itself. The bumper of the truck is definitely bent. Where does that energy come from? It takes an enormous amount of energy to bend those things. And all that comes from this amount of kinetic energy. Okay, let's now look at another problem.